G'day folks. Well, for today's equipment autopsy we have a Rinnai Infinity continuous water heater. It's a gas heater and it doesn't work. It was donated by a friend who got it off a friend just as junk. Also got this neat little oil cooler with the screw-on attachment to the oil filter housing. It's kind of neat. Don't know what kind of car it goes on, but that's worth keeping. This thing here, I just want to strip it down and get it out of here. Been raining continuously for the last 2 days, so I haven't had a chance to move big stuff outside like the engines and just clean up in here. I've really got to start pulling big things out and then get into cleaning, because otherwise you're just tripping over everything. Anyone who's got a hobby shop knows what that's like. So I'm going to pull this thing apart and you can stay and watch for the experience. They're quite interesting inside. I think that this one will have a stainless steel heat exchanger. A lot of them do. Or if we're lucky, it might have a copper heat exchanger. Be worth a bit of scrap. I think it's leaking. I don't know for sure, but I think it actually leaks, or it's got an electronic problem. Either way, I just want the circulation pump out of it above everything. Some of them do circulate continuous water for instant hot water. Okay, well there's the data on this water heater, for those of you who are interested in that sort of thing. Yeah, 44.5 kilowatts. That's pretty impressive. Of course, plenty of warnings. It is a gas appliance, so it's got to be approved and warranted. You can get LPG kits for these, but they're a bit hard to find unless you buy them brand new from Rinnai, in which case you're probably paying a small fortune. It's got the jet sizes there though. You can always plug the jets up with solder and then re-drill them. It's not hard to do. And of course everyone's crazy about energy ratings, although this one's faded out of existence. Yeah, it's a reason why a lot of people buy new appliances and throw the old one in the bin, is because it has a lower energy rating. Like a fridge that's down here will often get thrown in the bin, while it's perfectly good for a fridge that's up here in the middle. Big waste of a machine, a lot of expense making a new one and reprocessing, but that's what a lot of people do. So on with the autopsy. Oh wow, does this thing have a lot of crap in it for a water heater. That's what makes efficiency these days, making all this electronic crap. Like inverter microwaves and inverter air conditioners. They might be power efficient, but God knows what kind of consumables they used making them. I see a big printed circuit board with a rack of dip switches down there. Mains input, which is currently switched off at the panel, but neutral's still active. Now, we are going to put power to it and see what it does. It actually has a copper heat exchanger. One of the guys who works for Rinnai, when I was working at the scrapyard, he would bring in the whole back of his van full of these coils that had failed prematurely because they're made out of really paper thin copper. They just seem to have a horrible failure rate. Probably why this one was canned as well. There's a lot of signs of water getting through the bottom of the cabinet. There's a lot of corrosion and ongoing problem up there. Yeah, apparently these do have a pretty horrific failure rate. Don't worry, I'm not getting any kickbacks from Rinnai for doing this video. They probably won't like me. But this is quite a interesting unit. Always wondered what they look like. I've walked past them at the scrapyard before when they're complete with the cover on, just thinking it's just a burner rack with a valve on it and a copper heat exchanger, but this is incredible. Someone did say they had circulation pumps in them, which is I think that thing down there, and I guess they're right. There's 2 water passages, big aluminium manifold, and then it's going up to this heat exchanger. It's quite interesting, and obviously a combustion blower in there. That's a centrifugal blower. So let's turn some power on. Well, as they say in the movies, fire in the hole. I hear a valve or something. Sounds like servo motors and valves. And it's not doing anything. Probably waiting for a gas pressure signal, which is, that's gas input. Oh, I see, that's a gas manifold, not a water manifold. Silly me. Yeah, it's probably waiting for a gas pressure signal, like something from there. That looks like not so much a solenoid, but more like a pressure switch. Actually, no, sorry, it is a solenoid. I'm having a great night tonight. Yeah, that's not a pressure switch. That's a solenoid. Wonder how I could get this thing to do something exciting. Well, I guess I can't without fire and gas. Oh, let's just rip this damn thing apart. I don't have time for the fiddly mucky around stuff. I know it's busted. The guy said it doesn't work, so I'm going to take his word for it, and I'm not really going to bother using it for something important. They're not reliable enough. Well, I'm starting to get into the thing. It's not easy. There's the blower, which is packed up full of dead moths. Yeah, there they are. It's about 6 dead moths jammed inside it, so it's probably only got half the airflow it needs. And they're up inside the burner box. Cut that off so I can put obscene amounts of power through it. It's a 48 volt induction motor or something like that. Probably not actually, it's got so many wires on it. But either way, that thing will burn. Same with these silly little coils. It's just a retarded amount of complex stuff for a water heater. All you need for a water heater is a couple of thermistors or like wax stats, a burner rack, and a heat exchanger. Preferably made out of thick, heavy copper. None of this paper thin stuff. That's all you need for a heater. Mount it outside. Okay, if you want to put it inside, you do need a combustion blower, but that's about it. What's with all this electronic shit and sensors and things? How's that efficient? I mean, they're super efficient until they break, and you have to buy a new one. I don't know how old this thing is, but it's not very old. Oh, it's just so wasteful. I mean, I've dismantled quite a few instant and, well, I suppose you call them instant water heaters, particularly the old ones, the ones made by Junkers and Bosch. They are really simple. They have a solid brass valve block, a burner rack, and a copper heat exchanger. That's it. There's none of this stuff. There's no fancy valves or solenoids. Maybe one solenoid. That's about it. No thermistors like that one there. It came off the top of this loop. There's another one. There was another sensor there, which is down the bottom now. There's about 4 sensors on this copper part. There's a few on this burner box. There's 4 or 5 or so on the water outlet. Yeah, that's the outlet there, so there's a thermistor on that. There's some kind of sender on there with 4 wires going to it. There's wires going into a block down there. Why? Why do water heaters have to be so complex? This isn't saving energy, this is wasting energy manufacturing all this shit. I like high technology, but there's some places where it just doesn't belong. And if you build water heaters like big chunky bricks like they used to be, they can last until 40 years down the track when they eventually do corrode through, or it just gets so hard to buy parts that it's not worth replacing it, like the old Brivas Buffalo gas heaters. They lasted, my mum's one actually lasted 22 years before she replaced it with a Braemar. It was an EcoStar heater. And that Braemar EcoStar is not going to last as long as that 23-year-old Brivas Buffalo, because it's not built as well. Sure, it's efficient, but hey, when you're replacing them every 5 or 6 years, well, who cares about efficiency? Well, let's just buy a brand new one and throw it in the bin. Oh, enough ranting, let's go on with the autopsy. I'll try and get this whole assembly out all together. We can look at the PCB, we can figure out whatever the hell that valve block is, and hopefully I'll get something useful out of it, apart from just junk. Okay, well there's the electronics of it, all potted in epoxy or something like that. God help anyone who wants to service the damn thing. Nice little hot spot in there. No obviously blown caps or anything, it's definitely gotten hot though. Yeah. Definitely way too much crap for a water heater. I mean, this is a water heater, not a bloody computer. Yeah. We don't need that. We don't need that. A couple of valves in there, solenoids. Oh yeah. We have to let the smoke out of them. That's what I'm mainly interested in, but it looks more like a valve than a pump. I think some of these have water pumps, but I think this is all valve stuff. Solenoid valves to regulate the flow rate. Or stepping motor powered valves. So that's a bit unfortunate. There's no water pump in here, it's all just crap. Oh well, I'll keep the coils aside for letting the smoke out of, and let's dive into the rest of that. That's the burner box and heat exchanger. Okay, well that's the water inlet valve. Sorry, outlet. No, inlet. Sorry, this is the inlet valve. And it has a little DC motor, series of gears and other crap inside it. And it looks like a mode switch or something. Almost like a VCR mode switch. No, sorry, 2 hall sensors. So it knows where it is. It'll have a home position and an open position and just work between the two. Same with that one there, it's got gears inside it. And a little baby DC motor. A load of crap. That's the outlet with a temperature probe on it. That's part of the inlet that goes on the back of it. And that's the gas valve block with 4 solenoid valves on it. Quite interesting. Obviously there's a high burner and a low burner. They both open at once, or one or the other. So not too bad. That one's got a vacuum input governor for the combustion blower. If there's no vacuum inside the cabinet from the combustion blower, then it probably won't work. Oh, that's interesting. The gas input screen is plugged with tarry crap from the gas line. That might also be why it wasn't working. I don't know, these things are too sensitive. It'd be a shame if that was the only reason they threw it out, but you'd think the gas tech would really look at what he's doing before he throws the unit out. Then again, people just like replacing things for the hell of it. So let's go on with the heat exchanger and chuck the rest of this stuff in the bin. Oh, there's the ignition module. Tiny little thing. It says it uses 100 volts AC. Bit of a shame. Why do they have to use weird voltages? Why can't it be 12 volts? Make it easier to use as a spud cannon igniter or something. Got to get around to building one of those again. Get a proper potato gun going. There's another solenoid to burn up. The metal burner box with a filter screen or something inside, or an air restrictor. I guess the next step is to start taking screws out. Let's do that. Okay, well, I've got the combustion blower box off, or manifold, or muffler, whatever you like to call it, which is this bit here. I suppose you call it an air recycler, because the reason these are a bit more efficient than normal is simply because it recycles hot air. Now, there's no real air intake inside the rest of the unit. The case is pretty much sealed with the lid, apart from a few vents in it. And what's happening inside here is the blower is drawing air through here, it's pulling air down through here and blowing it into the box. Now this connects up here next to the flue. So you've got an inner flue where these little brazed or spot welded tags are supposed to attach to. You've got an inner flue in there for the exhaust gases to go through, but it's also pulling air down past that flue, which is preheating it. So you've got hot air coming into the burner box instead of ice cold air, and it simply means that the thermostat wouldn't have to cycle as often. It's one of the things that makes these units a bit more efficient on gas and heat, but they're still, in my opinion, a fairly cheaply built unit. I know they're not cheap to buy, but they're a bit overcomplicated anyway. They're probably not that cheap, but they're just overcomplicated. It is a very nice principle though. I like the idea of recycling heat as long as you can before it actually dissipates. I mean, the gas coming out the top of the flue would probably be cold enough that you can just hold your hand over it without burning yourself. Whereas a lot of gas heaters tend to vent an incredible amount of heat just to atmosphere. That's the only drawback with gas, is a lot of heat does go out the flue. And I like the idea of recycling it, but it comes at a price when you start incorporating a lot of electronics into it, like all this other crap they put on it. This design would work just fine if they didn't have the excessive electronics and thin heat exchangers, although I think this one might be alright given the other problems I found in the system, like dead moths inside the combustion blower and a blocked gas valve. So yeah, we'll hold off on the whole Rinnai shit thing, even though I've seen millions of these coils show up in the scrapyard in the last year or two, and they're not very old coils either. Oh, let's pull the rest of this thing apart before the video gets too long. You know, it's like trying to upload a 1 gig video to YouTube these days, it takes forever. Okay, well, I got the cover plate off the valve block, well, not valve block, but the burner. Not really much to it. It looks like these are the actual jets. There's tiny little holes at the bottoms of those bigger holes. I don't even think these have screw-in brass jets. We've probably just got a low setting, which is this passage here, going back down to there to the valve block. Probably a medium there. Probably incorporate both of those together as one of the settings. So you've got gas going to both of them, or just one of them. And we've also got a solenoid shut off here, which shuts off gas from this feed pipe into this bigger manifold. So you've also got the option of really high, like massive demand of hot water. This thing would just go into overdrive and open up all the valves and dump gas through every single burner. That's about all there really is to it. I don't think there'll be any adjustable or replaceable valves. It'll be this whole plate. If you wanted to convert this for propane instead of natural gas, you would have to buy this entire assembly. That's where they get expensive. But I'll pull it off. I might be wrong. There might be screw-in jets in each one of these holes, but it seems like an expensive way of doing it. I'm guessing it's just one die-cast piece, which is factory made with those holes cast in it, and that's it. Oh, those little inspection pilot light windows aren't glass either. That was mica. So don't stab them with a screwdriver or they end up like that. Yeah, pretty much what I expected. No brass valves to solder up and re-drill for propane conversion. You've got to buy this whole valve block. Kind of expensive, but that's what you get. Oh well, that's all scrap alley anyway. The rest of the box is fairly clear. I don't think it was an airflow issue. It's either gas starvation or an electronic problem. Yeah. Oh well, let's strip the rest of this thing apart and yeah, just keep the coil for scrap copper and go in that bucket there with the rest of it. Alright, definitely looks like there's been some leakage. Could be flux residue or something in there, but it's a bit odd. I don't know. Given the amount of other problems in this unit, it might not be a heat exchanger problem. Definitely a nice high efficiency burner though. This thing's heavy. It's really heavy. You get your small low pressure jets and you get your big high pressure jets in there too. It's quite a serious burner. I'll try and rip it apart and see what those actual fins look like. Yeah, there's a little burner tubes. I'll have to pull it out and pull it apart to see them, but they're stainless steel. These things are efficient, it's just the electronics seem to let them down. Probably gas inlet screens aren't big enough either. This one might have been fixable, but I've got no use for it. It's more fun pulling it to bits anyway. And there we go. That's the top section, nothing special. Bit of rust from condensate. And these are the burner assemblies. You can spend a bit of money on these things. It's a gas inlets, there's a little jet and a big jet. It's really neat stuff, but so disposable these days. And they're all stainless steel, I believe. Nope, they're not even real stainless. Chrome steel. Scrappies won't buy it if it's magnetic, even if they claim it's stainless or it's some kind of stainless. If it sticks to a magnet, you can forget about them buying it. Oh well, that all goes in the steel scrap bin. And that heavy lump of a thing goes in the copper bin, even though I think it's actually alright. I'll probably make a decent hydronic heat exchanger or something. Might be worth hanging on to. A bit of a shame these are magnetic, they're quite heavy. Oh, well, that's the end of that one there. Thanks for watching. And we also got these two other units. Another old Dakin non-inverter one. And a very old gas heating furnace. It's seen better days. Big heat exchangers. 2 burners. All been banged downwards. Might take that gas valve off. It's got a nice old-fashioned valve on it, and that's about it. The rest of it can stay on the trailer. I think even that thing can. I've got enough condensers at the moment. That's only some of them. This thing's a bit of a dinosaur. There's nothing really useful in it. It doesn't say when it was made, but it's old enough.